The malaria infection begins when an infected female, Nephili, mosquito, bites a person, injecting Plasmodium parasites into the bloodstream.
I don't know. Yesterday I threw up and like all these symptoms are just like starting to happen.
Oh
Like I
my
have
God.
chills, I have like,
Do you have fever?
yes, fever, like,
Oh my gosh, you have fever. I know you told me you were going out of town. Did you ever
yeah,
go on that trip?
last week to Puerto Rico. Me and my social group, we always like look on WebMD and I saw on there that it says something about like malaria,
wow.
something like that. But I only know that to like occur in Africa, and I didn't go to Africa or
Yeah.
Southeast Asia. Like I don't know.
I mean, it can happen a lot in large parts of Asia and Africa.
But I haven't went to any of those countries.
Another way to get it is by sharing a needle. Have you shared a needle?
Okay, between me and you, doctor, it was just one time. Okay, like it was only one needle. I didn't have a choice but to share it. And I'm in Puerto Rico. I just want to have fun like everybody else.
By sharing a needle, you can get malaria. And even though you're not pregnant, though you're not a young kid,
I know. I'm
you
just
can still get it.
doctor.
Because the pregnant women are vulnerable to it. You're not even pregnant.
Can you tell me more about this disease?
The parasite that causes malaria, Plasmodium falciparum, that's what causes it. It can destroy your red blood cells, and it can kill you. I would have to get a sample of your blood, and your blood will tell me if it's gram-negative or gram-positive. If it's gram-negative, you can narrow it down.
Well, what if what if their family or whatever? I don't know. Like, what if they like come for us, like come to attack us?
You don't have to worry about that because their family members, Rachinawi and the prey falciparum, those are both from the genus Plasmodium, and the Rachinawi feast on chimpanzees,
Okay.
and the prey falciparum feast on gorillas. But the falciparum from Plasmodium, those choose humans like you. From sharing that needle, it's a possibility that you are infected with it. The Plasmodium falciparum has evolved from wild living African apes.
Doctor. And I'm just here like an African American woman. Like I just wanted to travel and live my life. I didn't know all the consequences was gonna come. Like I didn't even know like this thing existed like here, in Puerto Rico. And now it's just like, lucky me, I guess. I don't know. I had another question. What do these things like? What do these things look like? Like, are they? Is it different form?
We have the ring stage.
Okay.
We have the trophocyte stage, schizont stage, and the gametocyte stage.
Okay.
The ring stage it has to deal with delicate cytoplasm. No, it's present when there's one or two chromatin dots. The trophocyte stage, it has cytoplasm with dark pigments.
Okay. I think that makes sense.
Yeah.
Okay.
Keeps getting dark. Schizont stage, parasites in the mature stage, and it's composed of 8 to 24 small merozytes.
So by that, then it's in its last stage, like.
No.
Okay.
Because the merozytes they're clumped in one mass, still with dark pigments. But then when we go to the last stage, like you said, it's shaped like a sausage with the chromatin in a single mass clumped up with the dark pigment. They came from the Lavagna family.
Okay.
And those are known to have parasites who love feeding off of gray apes, like humans, chimpanzees, and gorillas. The evolutionary lineage tree shows us that they came from the Lavagna family. Okay? But keep an eye out for all their relatives. Their evolutionary lineage came about 50,000 years ago, but it's only 3,000 or 4,000 years ago, we found out that there's parasites involved.
So, like, should I make a Facebook post or something?
Yeah. Tell your friends on Facebook to keep an eye out for their relatives.
Okay.
Their close relatives, which are Clostridium vivax, Clostridium malaria. They're also in charge of giving people malaria.
Okay. Thank you so
And
much, Doctor.
and it was just, I mean, I don't know how you don't know about this. 3,000 years ago, when we found out that these parasites, that they love to toast on humans.
Okay. I'm so sorry.
Not just gorillas and chimpanzees.
Hey! How was work?
Work was crazy. I had this crazy patient. He apparently has malaria.
What?
Playing with needles, yeah.
With needles?
Yeah. You can get malaria needles.
I had no idea. I thought that was something only in like Africa and that's it.
No.
How does that even happen? I only heard bits and pieces of it, but I have no way of knowing. How does that even develop?
Do you want to know?
Might as well.
I mean, you're playing pool. It sounds like a good example, right?
I got time. Let's do
I'll
it.
show you. So let's pretend this is the Anopheles mosquito, the white ball is, and this one is going to introduce sporocytes to the human host. Okay. And now as it progresses, your body starts changing and your liver cells get damaged. So now since those disappear, it starts the cycle of shutting down. And then pretend this is the cycle that continues. Then the sporocytes mature into schizoids that rupture and release merozytes.
That sounds deadly.
Yeah, they release the merozytes into the bloodstream. And now the bloodstream is still here, still going. As it goes in the bloodstream, now it affected this one.
So that red ball, the number 11, that's the infected red blood cells now.
Yeah, so since that's the last one I hit, that is the ring stage. The ring stage is where trophocytes mature. They mature into schizoids, who rupture and release merozytes.
Whoa.
Yeah, but then not all parasites are the same. But then some parasites, they can differentiate into sexual gamocytes. Now, we're continuing on because they're going to differentiate, right?
Right.
Okay. Now, since the cycle keeps going on, we have to keep infecting. We got to keep going. So now that one, oh look,
Now that ball's infected.
exactly. So now, gametocytes are ingested by Anopheles mosquitoes during a blood meal. And the male fertilizes the female gametocytes into the mosquito stomach. The mosquito stomach is filled with all that. Got it?
Oh, that's how he carries it.
Mm-hmm.
Got it.
Yeah. There it goes. It's all fertilized. Let's see where it ends up. They invade the mosquito's midgut. So now this is the midgut that is infected. This is the midgut, and it develops into oocytes. Ooh. So now here it goes. Developing into oocytes. And boom. The oocytes, they rupture and they release sporocytes. Since they release the sporocytes into the salivary gland. And these potential cells, they can get infected too.
Hey guys, what's up? Yeah, question.
Hey.
Why we gotta take all this damn doxycycline?
Well, actually, I'll be able to explain that to you. My sister's a doctor, but listen carefully because not taking it could actually hurt you.
What? Huh?
You're saying that while we're over here, in this crap hole, fighting for our country, putting ourselves in danger, that there's a possible chance that a tiny parasite could cause more harm to us than getting injured in battle?
What? Crazy, right? The doxycycline is there to stop the apicoclast organelle, impairing the parasite of protein synthesis. What kind of protein are we talking about?
chili, it's not an actual protein. It's a dihydrofolate reductase. It's an enzyme. The plasmodial surface anion channel. And the cytophores.
But dude, what do they do?
The dihydrofolate reductase speeds up the reduction of dihydrofolate to tetrahydrofolate, which is needed for purine, DNA, and protein synthesis, aka dihydrofolate reductase enables rapid growth. The plasmodial surface anion channel is an ion channel that helps parasites receive their needed nutrients and solutes.
And the permeability of this channel protein is needed in order for the parasite to develop. Cytopores also help supply iron for the parasite by playing a big major role of a binding factor. They bind and transfer iron, competing with the host, affecting its hemoglobin. Hey guys, but how does it get stopped?
The anti-malarial drug targets the parasite.
The pyrimethamine, for example, targets dihydrofolate reductase and it inhibits its function, leading to reduction of folic acid, which is needed for nucleic acid synthesis and malarial parasites.
Oh, okay.
What you guys looking at?
Hi, Dr. Tabears. I'm here trying to be a good student, and you're not even explaining to me the role of the parasite.
The role of the parasite is to kill the weak and to go after the ones who can't fight for themselves. The pregnant woman, the young woman.
But how is it possible that a parasite can use Anopheles mosquito and a human at the same time?
Sodium falciparum uses a mosquito as the host, and then the host, which is also the vector, transmits the disease by biting onto the humans. When he bites onto the humans, he injects the infected blood into them. Plasmodium falciparum loves to find mosquitoes that have a long lifespan so that the parasites have a good amount of time to develop.
Yes, doctor. I have another question. Where does Plasmodium falciparum get their energy from?
Sodium falciparum receives most of their energy through anaerobic glycolysis. Glycolysis allows glucose to be converted to pyruvate. Free energy that is released during glycolysis is released in the form of ATP and NADH. This process is able to increase the proliferation of the parasite.
I just don't get it. Why is iron toxic to the parasites? I thought iron was good.
Iron is very important to us, but it's also important to the parasites. The parasites need iron for DNA replication. The malaria parasite takes in about 25% to 80% hemoglobin for nutrition. The hemoglobin goes through hydrolysis in the parasite's acidic food vacuole, leading to spontaneous oxidation, which releases a lot of free heme. The free heme is toxic to cells. Spontaneous oxidation of heme iron forms superoxide radicals, hydrogen peroxide, and hydroxyl radicals. Since the free heme is toxic to cells, it has to be converted to hemosin, which is a malaria pigment. The oxygen from oxidation of heme iron of hemoglobin can be detoxified by doing superoxide dismutase to make H2O2, or in a spontaneous reaction with H2O2 to make OH.
Thank you, doctor, for teaching me everything that I know now. I now know that the chances of getting malaria, they're higher when the interactions between humans and ecosystems and infected vectors are so close and they're tight. Here in the United States, 1,700 cases are reported of malaria. Most of the cases are from travelers. That's us. We travel. We need to know. Malaria kills 500,000 people a year. Malaria is malignant. That means if it's left untreated, it has the potential to kill half of the people who are affected. Plasmodium falciparum is the most dangerous and most common cause of malaria. Now there's no successful anti-malaria drug out there. Now if we understand the invasion by the parasites on the host cell, maybe there's hope for an anti-malaria vaccine drug that we can have. And if everyone knows, then the chances of that drug coming to life is close.